Okay, so I guess we'll begin now. So, yeah, welcome to the second week of TA live session, and a very good evening to all of you. So today we'll be discussing some questions from week 3 because the week 3 assignment is due tomorrow if I remember correctly. And after that we'll just quickly go through the week 2 questions from the current assignment so that in case any of you have any doubts, uh, we can clarify that. So with that, without further ado, let's begin. Uh, by the way, you can hear me clearly and you can see my screen, right?
Yes, sir.
Okay, that's great. Okay, so let's get started. So in the last live session, there was a request for a better example or some more examples on the three forms of inference, basically deduction, abduction, and induction. So deduction, I'd say that as an like the example that we had discussed in the previous live session. So suppose if we are given that all actors are singers and X is an actor, then X is also a singer. This is a form of deduction. Uh, for abduction, you could say something like, so you're given that when the ball crosses the boundary, it's a 6. Okay, so it's an example from cricket. And you saw that the ball in air moving towards the boundary. So based on these two facts, you may hypothesize that it's a 6. But it might as well turn out that it's not a 6 and it's just a boundary, or it might be a catch and it might be an out as well. So abduction can or cannot be wrong. Okay, so abduction is mostly about coming up with possibilities. And induction, as we discussed, so different trees have green leaves, like mango tree has green leaves, guava tree has green leaves, apple tree has green leaves. So based on these facts, if we generalize and conclude that all trees have green leaves, this will be an example of induction. We know that this is not always true, there are exceptions, but we are making a generalization over here. So this is an example of induction. So just a few points I wanted to cover before we started for this week. I hope it helps the person who had requested for these examples. So let's start with the week 3 questions. Okay, so here's the first question in front of you. So you're given that the set of atomic sentences in propositional logic. I hope you remember atomic sentences from the last week's discussion. Yeah, so let the set of atomic sentences in propositional logic be P, Q, R, and S. Which of the following are sentences of PL? What do you think? Which of these options would be valid? Okay, so we have an answer. Orgodeep says A. Does anyone else want to contribute? Is A the only option, or are there more options? Okay, Orgodeep, do you want to elaborate on why you think A is the correct option? Maybe that will help some people.
Yes, sir. Because in the other options, like in the second option, we have the AND operator and also a bracket in front of it, which cannot be there
Yeah,
because it's a binary operator and you have to be only one operator. And also in the C, we have two binary operators, one after another, which is also not possible. Also, that imply and negation operator also is in front of R is there, so that is not possible. And also in D, there's the negation operator in between R and S, but it's a unary operator, so it's also not possible.
yeah, that's right. So you're mostly right, Orgodeep. Just one suggestion or correction I'll say that in C, you're right about having the and or operators together, so that is not correct. But you can have a
Yes, 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 the
negation.
second one is true. Yes, yes, yes.
You
Sorry,
can,
sorry.
yeah, you can have a negation after implication. Okay, so I'll just shift to Jamboard for a while. Yeah. So if we have sentences of the form, let's say alpha dot beta, where this can be any connective, okay, or we have just the atomic sentence or the negation of the atomic sentence, then we can say that these are correct or valid. But some of the options over here, like in B, don't satisfy this format. Okay, So that's why B, C, and D are not the correct options. A is the only correct option. So I hope that was clear. Yeah. Hi, Vipul. Good evening. So should we move on? Is there any doubt about this question? Okay. I'm assuming there's no doubt, but if there is, please do let me know. Okay. So here's the second question. Consider the following knowledge base, and we are given a set of information. Which of the following do you think can be derived from the knowledge base? So I'll give you some time to go through this and maybe try it out yourself, and then we can discuss the solution. Okay. Does anyone have any answers?
So E and F surely, and the others I'm still processing.
Okay. Okay. So I'll give you some more time. You can take your time. Then we'll discuss. Okay. Let's begin discussing, and then maybe we can see which of the options could be correct as we go through the examples. So we have a set of implications, and we have some or. So maybe we can write this in the form of an implication. So what would the first one be if we write it in the form of an implication?
Negation P implies R.
Okay. Can we write it as not R or P, or R
Yes,
implies
so
P?
just R implies P.
Yeah,
Yes, that
we
will
can
do.
write that. Okay, and from R and T, uh, we can write R and T, right? We can derive these two because there is an and connective in here. You agree with me?
Yes, sir.
Okay. Now using R implies P and R, can we write that we have P? Remember when we have alpha implies beta and alpha is given to us. Do you remember what this is called?
Yes, sir. Modus ponens.
Yeah, that's right. So we can derive P, right? Okay. I hope you agree with me. Then we have T implies not S. Okay. So using T and T implies not S, we can write not S, right? Also, we have W implies S and not S. So if we use these two, what can we write? Remember, suppose we have alpha implies beta and not beta. Can we imply not alpha from this? Remember what this is called?
Yes, a modus tollens.
Yeah. So can we imply not of W from here?
Yes.
Okay. So is there anything we are missing, or have we derived all that we could have derived from here? Let's go and check the options. So we see that we can derive P. We just saw that. Okay, let me use a different color. We can derive P. Then we can derive not S and not W. We also saw that, right? And we cannot derive the other options. S, W and not P, we cannot derive. So I'll give you a moment to verify this yourself, and if there is any doubt, please let me know. Maybe I'll shift to the Jamboard so that you can see the solution. Okay. Any doubts about this question?
Sir, if we break down P and S implies Q, can we get that negation P is true as well here? Anyhow,
Okay. How do you think we can do that?
from P and S, we can say that negation of P and S and Q is true.
Okay. So so if we break this down, we'll have negation of P and S or Q, right?
Yes.
Okay. And if we break this down further, we'll have not P or not S or Q, right? Do you agree?
Yes. Yes. Yes.
But since this is an OR operator, not an AND operator, we cannot infer not P from here, right?
Yes. 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 Okay, sir.
Yeah. Okay. So it's great. If there are no further doubts, we can move on to the next question. It's a similar question actually. The answers might be a bit different because the knowledge base is slightly different. Okay, so we are again given a knowledge base with some facts, and which of the following can be derived from this knowledge base? We have to find that out. Okay, so yeah, let's further simplify it in terms of implication. So we can write this one as not S or P, or S implies P. Agree?
Yes, sir.
Okay. And from S and W, we have S and W. Okay. Using this S implies P and S, we can imply P, right? Do you agree with me?
Yes, sir.
Okay. Now, using this W and W implies not P, we can write not P, right? So we have P and not P both in this case. Okay. Also, if you see, we have P and S. Right? So we have S here and we have P that we just derived. So using these two, we can write P and S. Right? And again, using P and S implies Q and P and S that we just derived, we can write Q. Okay. So we have derived S, W, P, not P, and Q till now. Now, are we missing something? Can you point something out that we are missing, or have we derived everything? Anyone? I'm audible, right?
Yes, sir. Yes, sir.
Okay, thanks. Can we apply modus tollens to anywhere over here? Do we have a situation where we have alpha implies beta and not beta? Okay, so I'll give you a hint. We have W implies not P, right, as a fact that is given to us, and we also derived P. So P is essentially not of not P, right? We can write P as not of not P, right? Do you agree with me? So given W implies not P and not of not P, what can we infer from this? Anyone?
Sir, W.
Can we infer W or not W? Remember, this is of the form. So W is alpha over here, not P is beta over here. So we have alpha implies
Yes,
beta.
sir. The negation of W. Yes.
Yeah, we can imply negation of W from this one. Okay, using modus tollens. Okay, sorry for that horrible handwriting, but I hope you can understand. So using P and this particular fact, we have not of W. Okay, so we have derived. Let's check whether we have covered some of the options or are some left. Okay, so we derived P. Let's mark these. Let's use a different color. So we derived P. We derived S and Q as well. Right? So we derived S here and we derived Q over here. We derived not P, not S, and not W as well. Right? We derived not P, not S. Oh, we have not derived not S, is it? We have derived not W. Can we derive not S using a similar modus tollens logic?
Yes, sir.
Okay. Which are the facts that we are going to use?
So P or negation S and
Uh-huh.
negation of negation P. Sorry.
Uh, you were right about S implies P, and we can use not P, right?
Yes, yes.
Yeah. So we can use this one. S implies P. Okay, I have written it in the form of a subset, I think. So sorry for that. This should be implies. Yeah. So S implies P and not P. Using this, we can write not S. right? Similar logic, modest tolerance. So we have derived not S as well. So this means that we can derive all of these options given this knowledge base. So was that clear? Any doubt about this particular question? I'll shift to the Jamboard. You can have a look and let me know if there's any doubt. Okay, so I'm assuming there's no doubt. Uh, that's great. So if you feel confused about anything, please feel free to write in the chat or you can unmute yourself and speak up. Okay. Okay. Uh, okay. I thought someone had raised a hand, but I guess someone is just joining. Okay. We'll move on to the next question, which is question 4. Okay. So this is a question straight from the lectures. So we are given that a model for a set of statements S in propositional logic satisfies which of the following conditions? What do you think fits for a definition of a model for a set of statements? So, do you remember the tabular method? Before discussing the tabular method, professor might have discussed about a model, right? Anyone? Any guesses? Even if you don't know the correct answer, it's fine.
Sir, B and D.
Okay. Uh, okay, so let's see. So you're saying B and D. Okay, so let B is exemplifies how statements in the logic can be written. So I don't think a model really tells us how the statements are written, right? Because statements are just in terms of, like we just saw an example, let's say P and S or P implies not S or something like that. Okay, so a model I don't think has to do anything with how the statements are written, right? Although it might seem that way because we are used to the definition of a model in terms of how something appears, right? But let's forget the English language definition of it. And uh, so I don't think B would be the right answer. Okay, so let's see what about D is a valuation for atomic proposition that makes half the sentences true. So if this is the case, what about the other half of the sentences? So if suppose if we have another model that satisfies or makes the other half of sentences true, would you call that a model? So would you call both those things a model? Okay, so Vanshika in the chat says that A and C are the right options. Again, like with the explanation we gave for B, uh, I don't think model has to anything to do with how we write the statements. But C, a valuation for atomic proposition that makes all the sentences in S true, that is something that makes sense, right? So if you revisit the lectures, you will see that the right answer would be a model for a set of statements is a valuation for the atomic propositions that makes all the sentences in S true. Okay, so Shekhar also says that C is the correct option. So thanks Orgodeep, Vanshika and Shekhar and everyone else who contributed. So I hope there's no doubt about this question. This is straight from the slides. Is everything fine? Should we move on to the next question? Okay, great. So we'll move on to the fifth question. So this is regarding the tabular method. So you remember we eliminate sometimes a connective from a sentence in a tabular to uh, expand things or simplify things, right? So eliminating a connective from a sentence in tabular leads to which of the following do you think? So first of all, when do you think we branch in a tabular method? Okay, so we already have an answer. Argodeep says C and D are the correct answers.
Sir, we branch when there is a or connective.
Yeah, that's right. That's perfect. And what if we have an and connective?
It will extend linearly.
Yeah. So does anyone else or do the others also agree that C and D are the correct options, or does someone think that A and B could be the correct options as well? Okay. So Somil also agrees that, and yeah, so you both are right. In fact, all of you are right. C and D are the correct options because there can be some cases where they can be further branching for some connectives, and there can be some cases where they can be a linear extension, but we cannot say that this always happens, right? So A and B are not correct sentences or correct options. So C and D are the correct options. Again, straightforward pretty much from the lectures itself. We'll move on to the next question, which is if we apply a tabular method to a given knowledge base, which of the following do you think we get as a result? Uh, is at least one branch should be a model for the knowledge base to be satisfiable, or at least one branch must be closed for the model to be unsatisfiable? Which of the following options do you think are correct? Or all branches should be models for the knowledge base to be satisfiable? Okay, so first of all, do you understand what is a satisfiability? So when would you call that a satisfiable model? Okay, so Isha says C is the correct answer. Does anyone else agree or differ from C? Okay, do you remember what is a tautology?
Yes, sir, where all statements are true, essentially.
Yeah. So when it's true for all possible arrangements, all possible configurations, yeah, that's right. Thanks, Shekhar. Thanks, Isha and Orkuti. That will be a tautology. But if we talk about satisfiability and unsatisfiability, even if we have some branches that are not true, okay, but there are some branches, at least one branch, if there is in the model, then we can say that it is satisfiable. Okay, at least one branch is the model for the knowledge base, then we can say that it is satisfiable. If all branches are models, then we say that the knowledge base is a tautology. But if all branches are closed because there is a contradiction in the tabular method in the columns, then we say that the it is unsatisfiable. Okay, the knowledge base is unsatisfiable. So was that clear? If not clear, we might have another question related to the same concept. Okay, Shekhar, you had a question. Please go ahead. Okay, so yeah, surely I can repeat. So in a tabular method, so you remember we expand the connectives basically, right? And when if it is a and connective, we expand it linearly. If it's an all or connective, we expand it into branches, right? As we discussed in the previous question. So we get different columns from the tabular, right? Basically. And when we have a contradiction in one of these columns, let's say we have a P as well as a not P in one of these columns, if you recall from the examples that professor used in the lectures, then we close that particular column, okay? So that is not a model. And if we have reached the end of all possible expansions and we still haven't found a contradiction, we say that that particular column is a model, okay? Now, if a particular tabular method results in all possible columns being not closed and we have finished all expansions, then we say that all branches, basically all columns, are models of the knowledge base, right? So means which means that for all possible configurations or interpretations, the knowledge base would be true. So that would be a tautology. If all the branches are closed, which means there's a contradiction in all the branches or all the columns, that would be unsatisfiable, right? Because we wouldn't have any model. And if there is at least one branch that is open at the very end, even if there are some branches that are closed, we can say that the knowledge base is satisfiable. Okay, so was that helpful, Shekhar? Maybe I'll show you an example from the lecture slides itself. That will make it more clear. Give me a minute. I'll just locate it. Yeah. So here we are basically uh, trying to expand this particular thing that was knowledge base that was given to us. Okay. P and P implies Q, and we have the negation of this. Okay. So we expand this negation and implies. Using that, we get P and P implies Q as 1 and not Q as 1. Okay, there is an and in the middle, remember. So basically, if you expand this implies, you will have a not of this whole thing, P and P implies Q or Q. And if you take into the consideration the negation on the very outside, it would lead to a negation of this first bracket, and it would convert the or to an and. Okay, so basically, if I do write it down, so we had P and P implies Q implies Q. Okay, so if we just expand this implies, we would have not of P and P implies Q or Q. And if we further expand this negation, we would have P and P implies Q and not Q. Okay, so this is what it's written over here. So we have this one and not Q. Then we further expand this particular bracket, which is P and P implies Q. So using this and connective, we have P and P implies Q. Okay, now using P implies Q, uh, so P implies Q can be further written as not P or Q, right? So there's an or in the middle over here. So this one, right? P implies Q can be written as not P or Q. Sorry, this one. Yeah. So we for branch into two possible branches. Okay. So we have not P or Q. Okay. So if you consider this particular column on the left, so you have not Q, P, and not P over here, right? So you have P and not P. So this is a contradiction. Okay. So we close this particular branch. Similarly, if you consider the right branch, you have not Q and Q over here, right? So there's a contradiction again. So you close this again. This basically means that this is an unsatisfiable model, right? And since we are using the negation of modus ponens, since the negation of the modus ponens does not have a model, we can say that modus ponens itself is sound. Okay. Okay. So that was clear. I think I went on for quite a while. Anyway, let's get back to the questions. So I hope that was clear. Yeah, Roshan, you had a question? Uh, Roshan, did you have a question? You had raised a hand.
Sir, by mistake, it's
Okay,
open.
okay. Yeah, that's fine. That's fine. So, okay. So let's get back to the question. So we have the second question or seventh question in front of us. So given the propositional logic language defined in the course, it is possible to have a knowledge base for which of the following do you think would be correct? Or I should say, rather look for which one would be not correct. That would probably be easier for you to guess or arrive at, deduce from the options. Remember, we have to confine ourselves to the propositional logic language that we have defined in the course. Okay, so what do you think about option C over here? Can option C be true based on the model that we have discussed? Not the model, the PL that we have discussed so far.
No, sir, three children is not possible because all are binary connectives.
Yeah,
And
exactly. Yeah, that's the perfect answer. So we can't have three children because using binary connectives allows us to have only two children whenever there is an OR operator or connective, right? So we know that C will not be true. What about the other options? A, B, and D.
Option B.
Yeah, that's right. Option B can be true. What about A and D?
yes, A and D also can be true.
Yeah, A and D can also be true. We have only one linear branch. Suppose it is filled with just AND connectives. We can have that, right? Or if it's just filled up with atomic sentences, right? Then D can also be true. So basically, except C, all the options are correct. Right? I will actually encourage you to maybe come up with a knowledge base that satisfies each of these three conditions. Okay, and you can share it in the next live session maybe. Okay, so that was pretty straightforward again. Okay, now moving on to the eighth question. So let alpha, beta, gamma, and delta be formulas over the set of propositions P, Q, and R. Okay. So let alpha and beta and gamma and not of delta be a simplified notation for the conjunction that is given over here. Okay. Which is basically alpha and beta bracket. So it is if we just open these brackets, we get this particular simplified notation. So given the conjunction as input, the tabular method can be used to show that which of the following do you think? So this basically asks you what is the possible output of the tabular method basically. What do you think? So what do you get as an end result of using the tabular method? Do you get to know that the let's say the conjunction in here is satisfiable, or do you get to know that it is unsatisfiable? or do you get to know that it is a tautology?
So tautology and satisfiable, because there will be no contradiction here.
Okay, but this is a general conjunction, right? You could also, we don't know what alpha beta are, right? So we are given that these are formulas. It might
Okay.
very well be that these end up being something that is unsatisfiable, right?
Yes, yes, yes. Because PQR is there. Yes.
Amardeep, did you have a question? Amardeep, if you don't have a question, maybe you can mute yourself. Thanks. Yeah, so Argadeep, you were saying, uh,
Yeah, because PQ and R, so it can be P or negation P. It can be anything. So it's not. It can be also not tautology.
yeah, so
There can be a
basically,
contradiction. That's what I'm saying.
yeah, that's right. So we can have something that is satisfiable, right? So A is correct, option A. And we could also have something that is unsatisfiable, okay? Now, in order to get something as a tautology or not, we need to have an extra step of inference from that, right? So if you remember from the lectures, if you have to prove something is tautology, we look for a model for not alpha, right? Do you agree with me?
Yes.
And when do we conclude that alpha is a tautology?
If not alpha is unsatisfiable.
Yeah, that's right. So basically, whenever we use a tabular method, the two results that we can get is satisfiable or unsatisfiable. Okay. And then if we have something in the form of a not alpha, and if it is unsatisfiable, then we can do an extra step of inference and say that since we have a not alpha and we have unsatisfiable, therefore alpha is a tautology. But using just the tabular method, we can just say whether something is satisfiable or unsatisfiable. Okay. So was that clear? Any doubt about that?
Sir, why is D false then?
Uh, because we are not proving anything, right? Are we? There is a there is a proof for not delta given alpha, beta, and gamma.
No, no, sir, D, not E.
Okay, D. The conjunction is satisfiable but not a tautology. Okay, because we can only say that the conjunction is satisfiable or unsatisfiable, right? In order for us to say whether it is a tautology or not,
Yes, we cannot prove. Yes, yes.
yeah,
Okay.
this is a too generalized, right? This is just basically to test whether you know what is the output of a tabular method.
Yes, yes. Okay, sir.
Yeah. Okay. So I hope that was clear too. Question 9 also kind of relates to tabular method. So the reason I'm discussing so many questions from tabular method is because I think there are some tabular method based questions in your current assignment. So I hope they'll be slightly helpful when you solve the current assignment. Or if you have already solved them, then maybe you can verify your answers. Okay, so in the tabular method, if no branch of the tabular being constructed for a formula alpha is closed, it means that, do you agree with me?
Yes.
Yeah. So Shekhar, I think you confused not being closed as not being closed, right? So we are told that no branch of the tabular is closed, right? So we have to have satisfiability. Okay, if all the branches had been closed, then we could say that it is unsatisfiable. Okay, this was also pretty straightforward, and this, I think, the 10th question will resolve any of the doubts you might still be having about this particular tautology, contradiction, or whatever. Okay, so you are given this Venn diagram basically. Okay, so you have to say what each of these A, B, C, and D correspond to. Okay, so A, B, C, D could either refer to tautology or a contradiction or contingency or satisfiable and unsatisfiable formula. Okay, so this basically tells us that D is a separate disjoint set. Okay, then we have B and C, and the union of B and C basically is what constitutes A. Right, so what do you think would be satisfiable over here? Which set would refer to satisfiable? Would it be A, B, C, or D?
A.
Yeah, that is right. Satisfiable would be A. And in that case, what would be B and C?
Tautology and contingency.
Yeah, that's right. So you could assign either tautology to B and contingency to C, or you could say that B is a contingency and C is a tautology. Okay, so a satisfiable is basically the combination of tautology and contingency. Tautology means that it's true for every possible valuation or interpretation or configuration, and contingency basically means that there might be some configurations for which it is true, for others it might not. Okay, and D is basically we are left with contradiction or unsatisfiability, which are basically the same things, right? So we have A is the A part of the Venn diagram is that is constituting of B and C, that is satisfiable. Unsatisfiable and contradiction, which are both the same things, refer to the D part, and tautology and contingency refer to the B and C or C and B, depending on the way you assign these particular values or answers. Okay, so I see Vanshika had also contributed in the chat, so thanks for the answer, Vanshika. So I hope this was clear. Any doubt about this? Okay, I guess it's all clear then. Okay, so we are now at the last question that we are going to discuss from week 3. Okay, so here we are given a setting. Okay, so consider the following atomic sentences and the propositional and their uh, proportional representation. I guess there is a typo over here, as proportional variables. Okay, so we have C as Bob can make a call, D as the battery is dead, H is the Bob did not change, Bob did charge the battery. We have Z as the balance is 0, and T as Bob topped up the phone. So first of all, are all these atomic, or are some of these non-atomic?
Yes, sir. Atomic.
Yeah, that's right. All of these are actually atomic sentences. So what we have to do is we have to represent the set of sentences 1 through 5 shown at the bottom in terms of these propositional variables, basically C, D, H, Z, and T. Okay, so let's consider the first one. Bob cannot make a call. So how do you think we can represent this? So remember, C is Bob can make a call. So how would you represent statement 1?
So negation C.
Yeah, that's right. Uh, Similarly, the second statement is the balance is non-zero. So how would you represent that?
Sir,
Remember?
negations Z.
Yeah, that's right, Orkudeep. And Vanshika also wrote in the chat. So we will have negation of Z or Z. Okay. What about the third statement? If Bob does not charge the battery, then it is dead. So here we might have a combination of two of these variables.
Sir, negation H implies D.
Okay. So let's see. So let's dissect it into two parts. So one is if Bob does not charge the battery. Okay, and H says Bob did charge the battery. Okay, so if not of H, that is if Bob does not charge a battery, implies it is dead, right? So not H implies D is actually correct. Yeah. Thanks, Orkuti. Yeah, thanks, Sunil. He also wrote it correctly. Not H implies D. Okay. What about the fourth statement? If Bob tops up the phone, then the balance will be non-zero.
Sir, T implies not Z.
Yeah, that's right. Because T says Bob topped up the phone and Z says the balance is zero. So basically balance would be non-zero when we have not set, right? So T implies not set. Okay. What about the last one? If the balance is zero or the battery is dead, then Bob cannot make a call.
So Z or D implies negation C.
Okay. Yeah, that's right. So does everyone agree? Has everyone understood this? Any doubts about this particular question? I'll show you the answers that we just saw. So Sunil, I guess you wanted to write Z or D. That might have been a typo. I hope, right?
Yeah, yeah,
Yeah.
that's right. Thanks.
Okay. So if there are no doubts about these, then yeah. So we have discussed the week 3 questions, and we can move on to discussing the week 2 questions from the current assignment if there are any doubts about them. Okay. So first of all, any more doubts you have from week 3 that we should discuss? Okay. Okay. If there are any, please let me know. By the time let's move on to the questions quickly. Okay, so the first question was sentence in logic is a statement that in principle has a truth value. Okay, which of the following are sentences in logic? So does anyone want to explain why these are the right options? You might already have attempted this quiz, right? Because the due date has passed. So which of the following do you think, or why are the right options right, do you think?
So because they have a truth value.
Yeah, pretty much. That's the
Yeah,
answer.
correct.
Yeah. Thanks, Somil and Sunil. So we see that statements like the sky is red and the sky is not red can be given true or false values, right? Similarly, for the document is not in Paris and Mr. Hercule Poirot, or I'm not sure I'm pronouncing it correctly, knows the location of the document. But the other statements like tell me the color of the sky or do you know the color of the sky or ask Mr. Hercule to take the document to Paris, these cannot be assigned true or false values, right? So these are not the correct options. Okay, True or false? Abduction is a valid inference method in propositional logic because doctors use abductive reasoning to hypothesize a diagnosis. Why do you think is this false?
So because it is not sound
That's right.
abduction, yeah.
Yeah, that is perfect, Somil. So I think professor also discussed or why abduction is not sound. You can revisit the lecture for that. And if we just have to look at it in an intuitive way, so when the doctors used abductive reasoning to hypothesize a diagnosis, okay, so when you go to a doctor, he or she listens to your symptoms and then comes up with what might be the possible disease that you're having, right? And then prescribe medicines accordingly. But this may or may not be true, right? So the doctor is making a decision, a deduction based on some partial knowledge that may or may not be true. And that is why many times doctors go for these diagnostic tests, right? You have to give your blood or something. Uh, so basically what we are deducing may or may not be true, right? So that's why we can't say that abduction is a valid inference method. Okay, so I hope that was clear. Okay, so when the statement P implies Q is true, what does the statement convey? So suppose we are given P implies Q and P is also given to us, which means that P is true, and we also know that P implies Q. So what can we infer based on that?
Sir, basically, if P happens, Q will happen. If
Hmm.
Q happens, P can happen or cannot happen. That is not needed. That is basically.
Yeah, that's
Some
true.
modus ponens and modus tollens. Those
Yeah,
two inferences.
exactly. Thanks, Somil and Orkutip. So basically, if we have P implies Q and P, then we can directly say that Q will be true, right? From modus ponens. And if we have P implies Q and not Q, basically modus tollens, we can say not P or P is false, right? So these are the only two things we can infer from this. Hence, these two options are correct. When P is true, Q will be true, and when Q is false, P will be false. Okay. Now select the valid rules of substitution from among these. Okay, so let's take these options one by one. So first we have P is equivalent to Q. This is equivalent to P implies Q or Q implies P. Why is this not correct? Or what could have been correct if we had to correct this option?
Sir, the or in between should be and.
Yeah, that's right. Does anyone else, do the others also agree?
Yes, sir. Yes.
Yeah, that's basically it. So if P implies Q and Q implies P, we can say that P and Q are equivalent. But here we are given an OR, so that option is the first option is not correct. And the second option is P implies Q is equivalent to not P or Q, which is basically just the expansion of implies, right? You can also verify it using a truth table because these are very short formulae. So you can just verify it using a truth table as well. And we have P implies Q is equivalent to not Q implies not P, which is basically a way of rewriting modus tollens, right? We just saw in the last question when Q is false, P will be false, right? So P implies Q is equivalent to not Q implies not P. So that's why the third option is correct. And the last option, P and Q implies R, we cannot say that P implies Q implies R, right? Because those are two different connectives, and implies. We can also verify it using truth tables. So any doubts about this particular question or should we move on? Okay, so I guess this is pretty clear. Okay, the fifth question was select the valid rules of inference. Okay, so is the first one valid? We have P and P implies Q, and we are proving Q.
Yes, modus ponens.
Yeah, that's right. And we have, so that the first option is correct. Then the second option we have P or Q, and this statement says that if we have P or Q, we can prove that P and Q. That doesn't make sense, right? Yeah. So basically that's why the second option is not correct. And the third option is not P and P or Q. So we know that P or Q has to be, either P or Q has to be true, right? We are given not P, this which means that P is false. So Q has to be true, right? Because P or Q is true. So the third option is correct. And the fourth option is not Q and P implies Q. So we can infer not P from here. Which is like the nth repetition of modus tollens we are seeing over here. But I hope the options are clear. Any doubts about this question? Okay, thanks for the thumbs up, Soman. Okay, the sixth question was which of the following statements about entailments are correct? Which is basically another way of discussing all that we had been discussing just till now. So we are given P and P implies Q. Again, we can say that Q is entailed. And if we are given P implies Q and Q, we cannot say for sure whether P is true or not. So yeah, this P is not entailed. So second option is also correct. And we are given P implies Q and not P. We cannot infer whether not Q is true. So this is also not entailed. And again, the fourth option is modus tollens again. So this is also correct. So all four options are correct in this case. Any doubts about this one? I apologize if I'm being repetitive in asking if there are any doubts, but if there are, just in case, I'm making sure. Okay, thanks, Somit. Okay, the seventh question was select the correct statements. So why do you think the given answers correct? So this is basically going to the definition of entailment and proofs. Right? We had a few questions related to that in the previous live session as well. Anyone wants to say what entailment is?
Given a knowledge base, finding all the necessarily true statements, isn't it?
Yeah, that's right. That is also what one of the right options says, that knowledge base entails P, means that when all the sentences in knowledge base are true, then P must also be necessarily true. So that is correct. Right? And the other option regarding entailment was that KB entails P, means that from the sentences in KB we can derive P using a bunch of inference rules. That is not correct. That is actually what we do when we are proving something, and hence the other option, the last two options related to proving, we have to look at that. So when we say knowledge base can derive P, means that from the sentence in knowledge base we can derive P using a bunch of inference rules. That is the derivation or the proof. Yeah. So again, pretty much straightforward. Yeah, I don't think there will be any doubts about this one. So let's move on to the next question. Yeah, I think we discussed this very say exact question, or maybe not exact, but a similar, very similar question in the last live session. A knowledge base is a set of sentences where all the sentences are assumed to be true. That's the basic definition of a knowledge base. Yeah, I don't think there's any doubt about this one either. Okay. What is the total number of binary connectives that are possible between two Boolean variables, say P and Q? I think there was a doubt about this particular question or this particular something related to this question in the last live session, and we also discussed that. So does anyone want to say why it would be 16 and not 2, 4 or 8?
Regarding two connectives, there will be the four rows. So each rows can two values, either true or false. So 2 power 4 will be the answer.
Yeah,
And generally, basically, we use the formula 2 power and also we can use.
yeah, both explanations are correct. Another way you can approach this is you can say that we have two Boolean variables P and Q, right? So you can assign two possible values to each of these 0 or 1, right? Similarly, you can have not P and not Q. You can also assign two values to these 0 and 1, 0 and 1. So ultimately, you will have 16 as the answer. Okay, so this is also pretty much straightforward. So which of the following set of connectives are complete in propositional logic? So we have the answers, but can anyone tell what exactly is meant by complete set of connectives? Set of connectives that are complete.
It's like they are enough to prove all the statements.
Yeah, that's right. Thanks, Somil, and thanks, Naresh, for the previous question as well. I forgot to thank you. Yeah, that's pretty much it, what Somil said. So we know that and, or, and not, and similarly and not are complete, and implies and not are also complete. But implies alone is not complete. That's why implies the first option is incorrect and the other two options are correct. You can also try to verify this for yourself by trying to derive all the uh, and or not, NAND, NOR or SOR in terms of uh, these particular set of connectives. Okay. The next question was about what is a proof or derivation in logic, and we had discussed this the last time. We'll just go through the options once more. Involves preparing the truth table for sentences for the sentence P. That is not true. Involves the use of rules of inference to derive P from the knowledge base. Yes, we do that in a derivation. Is a syntactic process that does not bother with the truth values of the sentences that are read and or derived. That is also true. We don't concern ourselves with the truth value because the truth values are externally supplied, right? And the last option is a syntactic process that analyzes the real world meaning of the sentences that we wish to prove or derive. That is not true uh, because we are solely concerned with the uh, derivation process and not whether it holds meaning in our real world scenarios. Okay. Any conclusion about this question? Okay. Thanks, Somil. Uh, okay. So the 12th question was kind of repetitive actually. A proof procedure in logic is said to be sound if dash and dash. So does anyone remember from the lectures or from our discussion the last session what is soundness and what is completeness?
Yes, so soundness is only true statements and completeness is all the true statements.
Yeah, perfect. Thanks again, Swamil. So that's why these options are correct. That it can derive, it's sound if it can derive true sentences and it cannot derive any false sentences, right? And those are the two correct options. And the second option is not correct because that would be complete, right? It can derive all the true sentences would be referring to a complete uh, setting. And it may derive some false sentences is also again is not correct because soundness has to agree with deriving only true sentences. Okay, uh, so that was it. And I guess we also discussed the next question while discussing the previous one, which is that a proof procedure is complete, then it can derive all the true sentences and it may derive some false sentences. Was there a hand raised? Did I miss something? Okay, okay. I guess there wasn't. So again, pretty much straightforward. Okay. A tautological formula in propositional logic is a sentence that evaluates to true when its variables are set to true is correct, right? Or is it not correct?
It's correct, sir.
Is it?
Like the B option to any combination of two.
Ah, right. The B option. Yeah, the B option is correct
Yes, yes. Sorry.
because yeah, uh, tautological formula in propositional logic is a sentence that evaluates to true when its variables are set to any possible configuration of truth values, right? So not just when they are set to true, but any possible configuration would result in true. And it is used to test whether a rule of inference is valid or not, and it is used to test whether a rule of substitution is valid or not. Okay. So I'll just let you go through the options while I just have some water. Okay. Give me a moment. Yeah. Sorry about that. I'm back again. Yeah. So we'll move on to the next question if there's no doubt about this one. Okay. So we discussed similar questions again in the previous live session. The document must be in Paris or it must be in Milan. Right? The document is not in Paris, therefore the document is in Milan. This is a valid conclusion. So how would we represent this in terms of uh, variables if we have to put it formally?
P or Q and not P.
Yeah, that's right. So here we basically have the document must be in Paris or it must be in Milan. So if we assume that the statement document is in Paris to be P and document is in Milan to be Q, the first sentence would refer to P or Q. And the second statement is the document is not in Paris, which basically is negation of P, so not P. So we have P or Q and not of P. And since we are given not of P, we can say that the document is in Milan, right? So Q is true. So this is a valid conclusion. By the way, just in case, any doubts about this question? Okay. Thanks, Somil, again. Uh, by the way, I hope everyone else also agrees with Somil. Uh, If not, please let me know if there's any confusion. Okay, the next question was, if it rains, then the grass gets wet. The grass is wet, therefore it rained. So how do we represent this one?
P implies Q and P, the famous modus ponens.
Yeah, so you're right about P implies Q, if where P is that it rains and Q is that the grass gets wet. But we are given P implies Q
Yeah,
and
sorry, and
Q.
Q.
Yeah, that's right. We are given the grass is wet, so which is Q. So we are given P implies Q and Q, using which we cannot infer that P is true. So therefore, this conclusion is not valid. That's why this no is the correct answer.
This is what it is confusing.
Uh, what's confusing?
Okay, if it rains, the grass is wet.
Yeah. So just imagine that we have
The
P.
grass is wet.
Yeah. So
So
just
naturally, it has rained.
no. What if someone had watered their garden? That's why the grass is wet. There could be any number of reasons, right?
But the statement, no, the limiting our analysis only to the statement,
Yeah. Okay.
not
Let's
stretching our
let's
imagination outside the statement.
let's write this down. Okay. So we have P
Okay,
equals to it rained, and Q is grass is wet.
wet, wet.
Okay. So the first sentence says that if it rains, the grass will be wet,
Yes,
and the second statement says that the grass is wet. So
yes.
is there any derivation that you learned, modus tollens or modus tollens, that tells us that if we are given P implies Q and Q, we can derive P?
Not. I remember that.
Yeah, we don't, right? Because we can't. So if you had been given P instead, then you could have implied that Q is true from modus tollens. Or if you had been given not of Q, one second,
Okay.
yeah, then you could have
Can you
implied.
modify the statement?
No, we can't modify the statement. I'm just giving you examples. Uh, if we
No,
had
no,
been
no. What
given,
I'm asking,
uh-huh,
no, no. What I'm asking,
uh-huh,
let's forget everything.
okay,
Let's forget everything and get back to the question,
okay.
and let's really work through to get the answer yes.
No,
How do the can should be framed?
why do you want to get to the answer yes? Like, is it for this particular question or in general you
No,
are saying? Like you're
no,
asking, you're
for this
asking,
particular question, what type of situation will you make to yes?
okay, okay. So suppose the conclusion had been instead of therefore it rained, okay, suppose the situation had been you had been given if it rains then the grass gets wet and you had been given it rained, okay, and you concluded
Yeah,
the grass is wet, then the conclusion would have been valid. Or if you had been given if it rains then the grass gets wet as one sentence, or and the second sentence would have been the grass is not wet, therefore you concluded that it did not rain, that would be a valid conclusion. Okay.
okay. So if suppose the question is framed like this,
Mm-hmm.
there is no rain and the grass is not wet.
There is no rain and the grass is not wet, so you still have P implies Q, right?
Yeah, still I have P implies Q, but in the negative.
And you're saying there is
In the
no
negative.
rain, that is it, not P is there.
There's no rain and the grass is not wet.
Okay. Yeah.
Yeah. That time the answer is yes.
So using P implies Q and not Q, you can derive not P, right?
Yeah,
But
here is also same thing. No, P implies Q, and Q is not implying P.
Where in the question that we discussed?
Yeah.
No, here you are
No,
given
the modified question.
this one that we discussed right now. This one?
Yeah, right now, what we are discussing.
Yeah.
I
In that
changed the
case,
question.
yeah. In that case, yeah, it would be not P would be a valid conclusion because you're
Okay.
using modus tollens over here, right? But that is not the
Okay.
question that is given to us.
No, that's not the question.
Yeah. So the question that is given to us, the conclusion is not valid.
Okay, I got it.
Yeah.
Thank you.
Yeah. Okay. Thanks for that, Mohan, if I remember correctly, right?
You're right.
Yeah. Okay. Okay. So, so we have one something that we just discussed, Mohan, for your reference, 17th question. So we are still given if it rains, then the grass is wet. So P implies Q, and the grass is not wet, not Q, right? So we have P implies Q and not Q. Therefore, it did not rain, not P, right? Modus tollens. So this is a valid conclusion.
So it is there. Yes. Thank you.
Yeah. So, okay, just to round up, any confusion about the three questions we discussed till now? The last three questions. Okay. Thanks once again, Somil, for the thumbs up. And so these are pretty much the questions from week 2 that were there in the current assignment that I guess most of you, if not all of you, would have attempted and submitted. And I hope that most of you scored full marks. But even if it's not the case, that's fine. You still have 11 more weeks to go, so there's enough time. So we still have around half an hour. So I'm willing to stay back if anyone has any doubts. Otherwise, you are free to leave if you want to leave. Okay, thanks for attending.
Thank you.
Yeah. If there are any doubts from week 2 or 3 or any of the weeks till now, except week 4, because week 4 is yet to be discussed. We'll discuss it next week. You
Week
can.
3. Week 3 are going to discuss.
Week 3 we discussed it from in the first hour of the live session. Yeah.
Okay, so it's recorded.
Yeah, it's recorded. It will be made available latest by tonight, midnight.
Okay.
I suppose the spreadsheet that I was talking about must have been shared with you, right? Can you access it?
Yeah, I saw the spreadsheet, and it's not. The link is not yet established because I think apparently after the class is over, it will be established.
Yeah. The week 2 recording. So after we finish this particular session, I'll process the video and I'll upload it. It might take some time, but it'll be. I'll update it by midnight. Yeah.
All right. I find it difficult only the AI intro. That's where it's real trouble is.
Which one? Sorry.
Introduction to AI.
The
That's where,
first week you're saying,
uh,
or week 0? Do you mean?
I got to see my marks because one of the week was very bad.
That's fine. Uh, that happens, but you can always make up, right? And this is more about the learning process, right? So you'll get used to the quizzes once the weeks progress.
I thought that I understood very well, and when I was tested, it's proven wrong.
Okay. So which week was this from? Week 1, or do you want me to discuss any of those questions? Any particular in
Introduction.
specific questions?
Yeah, which I'm just saying that one.
Yeah, sure. I remember one of the weeks involved viewing some, one of the assignments involved viewing some videos, I think, and then answering.
Assignment 2, yes, it was the second week.
Yeah, so maybe that we can't discuss because I haven't seen the videos and I don't think we
That's a
have time
Boston
to.
Dynamics stuff, no?
Huh?
That's a Boston Dynamics stuff, no? Where all these,
Okay.
yeah, that's the one exactly.
Okay, let me go to that week. This is week 2, you're saying, right?
But it is not. It's that's on the introduction to artificial intelligence, not in this subject.
Oh, that is a different course you're saying, is it?
Yeah, different course altogether.
Ah,
Yeah.
okay. Okay, I am not answerable for a different course then.
Yeah,
I am not
I, I,
aware.
yeah, I expected that you may not really
Yeah,
go
yeah, yeah.
session.
So there might be TAs for that course, right?
Yeah,
Yeah. So
yeah, I'll wait for that one.
yeah, sure, sure. You should ask the TAs. I hope they'll definitely resolve your doubts. Uh,
Right. Okay. Suppose if you miss some of the classes,
mm-hmm.
and some other class we can really get back to older questions, and you still continue to clarify that.
In the live sessions, you mean?
In the live sessions, suppose if I say, for example, today I just lost the first half of the class.
Uh-huh, uh-huh.
Okay, so I don't know what you discussed here, but after only seeing that only I can ask the questions. So the next class, can I talk about the week 3?
Yeah, yeah, for sure, for sure. No
Okay.
issues with that.
All right. All right.
Yeah.
Thank
Actually, if you check the drive folder link that was in the spreadsheet, I've already uploaded this slides, right? So you can also go through the questions that we discussed from week 3, and if there's something in particular that seems off, we can discuss it right now as well. Or if
you.
you would like to take some time to go through the questions and come up the
Yeah.
derive the answers yourself, we can discuss it next week as well. That's perfectly fine.
That's already loaded in the portal.
Not the portal, but if you go to that spreadsheet, I'll just share my screen. Maybe that will help you. Okay, so uh, I hope the Swayam portal is visible to you guys, right?
That is a spreadsheet.
So if you go to this problem solving session, right here, there is a click here option, okay?
Problem. So yeah, yeah.
Okay, you can't see the screen. Can you see it now?
Yeah, I'm just parallelly working with you, and I'm
Uh-huh.
trying to.
So that will lead you to a spreadsheet where I'll be updating these links to the YouTube videos.
Okay, so right now it's not there, I think.
Yeah, week 2 video is not there, but the folder link is common for all weeks. So if you go to this particular folder, you'll find that the week 2 slides have already been uploaded.
Yeah, week 1 and 2 is already uploaded, but not week 3. Week 3, you said you are going to upload it tonight, is it?
No, I mean week 2 of live session, okay? That is not the same as week 3 of the content that we discussed in the lectures. So the second live session, that is the one we discussed today, included questions from week 3 lectures and the week 2 assignment.
But week 3 submission is tomorrow, is it?
Yeah, yeah. Week 3 assignment is due tomorrow.
But you already discussed it today.
Yeah, we discussed it. I mean, I did not discuss the assignment questions that you have to answer. I discussed the questions from the previous year, basically.
Oh, okay, okay, got
Yeah,
it, got it.
yeah.
I thought you made the life simple simply by discussing our
No, no, no.
questions.
I can't do that. That would be unfair for people who are not attending or not being able to watch the live sessions, right?
Okay, right? Thank you. All right, that's about now. Thank you very much.
Yeah. Thanks for attending. So I'll stay back for around half an hour. If there are any doubts, please let me know. feel free to ping me.
Okay.
Yeah.
But in these slides, you're not given explanations. No, you're just simply picking the right answers, but you didn't tell about why the other options are wrong.
Yeah, because we discussed that, right, in the live session. So if you want, we can go through some of these questions. If there are any specific questions you want to discuss uh, in the half an hour that we have.
No, I don't have a specific question. So unless I go through it and find it out.
Sure, sure, sure.
Yeah.
You can take
Thank
your
you.
time, uh, and we can discuss it next week as well.
I'll do that. Thank you.
Vipul, did you have a question? You're unmuted. Vipul, am I audible? Uh, Vipul, do you have a question? Okay, I guess you got unmuted by mistake, so I'm just muting you. But in case you have a question, you can feel free to unmute yourself. Okay. Maybe I'll just scroll through the week 3 questions we discussed, and yeah. Yeah, Somil, I was considering that we used to do that for one of the courses that I used to TA for earlier. Maybe that will be a nice thing to incorporate. So yeah, I think that's a very nice suggestion. We could incorporate polls so that people who don't usually speak up or write in the chat, even they can answer through the polls. Yeah, that's a good suggestion, Somil. Thanks for that. I think Google Meet itself provides some options to use polls. Maybe I'll try out one poll and see if it works. Okay, I'll uh, just load the first question of week 3 that we discussed, and I'll just put in the question. Okay, A. Okay, so I have launched the poll. Can you see it? Those who are in the meeting, and if you can I just vote so that you can try it out? Okay, so we have one vote for option A.
Saw the poll request, but I lost it now. I'm not able to see it.
Yeah, so Mohan, if you go to your bottom right corner of the Gmeet, right, you'll see a symbol with a triangle, square, and a circle called activities.
Yeah.
Yeah, if you go over that, you might be able to access the poll.
Okay. All right. Okay. I have that one.
Yeah, we have 2 votes. Yeah, this is nice. Yeah, we can incorporate that from the next live session onwards.
Okay.
Yeah.
What are the other options available on that one?
In the question?
No, in that activities. When I click only polling is there. Nothing else. No?
Yeah. Because so the other options are Q&A, but I don't think, I mean,
Whiteboarding, you can write it, is it?
yeah, but I usually prefer to use a Jamboard that I shift to because I think it's more convenient for me. Yeah,
So anybody, if even if I can create a jam, it will be coming there.
yeah, it will come
It's
there.
visible.
But in that case, what will happen is then anyone in the meet will be able to edit on that Jamboard, right? So we could do that as well if we want to collaborate on some answer, discuss it.
My Jamboard is visible now.
If I click on the link, I think it will be visible.
No, no, I have not shared it. If I share, that will probably do.
No, no, I think it got shared as a chat message.
Oh, really?
Yeah.
Yeah,
So,
but we didn't have access to that.
okay, that's fine. We can
Okay.
continue with the Jamboard setting that I use. Uh, by the way, Ashwini has sent another suggestion. So about the video lecture classes. Uh, Hi, yeah. So Ashwini, I'll convey this to Deepak sir, but I'm not sure whether this can be changed in this run of the course because the videos are already re-recorded, right? So yeah, I'll make sure to give this feedback to Deepak sir. But
Yes, sir. Thank you. Thanks
yeah,
a lot.
yeah. Okay. So the other options among the activities that we have are something called the breakout rooms, which is splitting the group into smaller groups of discussion. Okay, but I don't think that will be helpful for our case, right? Because we already have few participants who are shy to discuss the questions. So splitting them into further smaller groups, I don't think would lead to any helpful discussion. Okay, so maybe we can incorporate polls and jam boards from the next live sessions. And as for Q&A, I guess people can just continue to write their questions in the chat and or just speak up, unmute themselves, and that could work. Okay, I'll still stick around for some time. Also, by the way, so are you guys doing the KRR course for the, or have you done the complementary course offered by Deepak sir, like AI SMPS search methods for problem solving? Is there anyone from that course that is also taking this course currently?
Yes, sir. I took that in the last iteration, and I also got the certificate.
Oh, that's
So
nice.
me too. I took the SMPS.
Yeah, that's nice, Kamil. I think I your name seemed a bit familiar to me, so maybe did you take it last semester or before that?
Yeah,
Yes,
yeah.
last.
Just last semester, sir.
Okay, that's why. Okay, that's nice. It's nice to see some people from SMPS also joining the KRR course. And it's nice to see that you have interest in this subject.
I had taken only KRR, not the SMPS. I had not yet completed.
That's fine. You can try it out next semester. I think it will be offered next semester.
No, it sounds that it's a prerequisite for the KRR
No,
actually.
no, 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 no. It's not a prerequisite as such. It's the complementary part of AI. So
Okay.
here we are dealing with knowledge representation and reasoning, and in that course we mostly deal with different search methods basically. Okay.
Okay.
Yeah. So there is no need as such to have done one course to understand the other one well. You
Sir,
can,
which
Okay.
one's the KRR?
huh? Sorry.
Which one? Which courses are you talking about? The search methods one.
Yeah, SMPS is the search methods one, and the one we are currently in is the KRR one, the knowledge representation and reasoning that
Yes, yes,
that we are having live sessions for.
yes, yes.
Yeah. So how did you find the SNPS course overall? Did you enjoy it? Was it? Uh,
Yes, sir. It was great. Like just before the final examination day, I decided that I will, have these 12 hours, and I will see all the recording sessions. These are the ones that helped me actually. They were
okay,
all theoretical, practical questions in the exam, not any recall questions. The questions were good, and these recording sessions helped a lot.
that's great. I'm glad the recordings help. Yeah, mostly I think it will be like that. Recall questions will be fewer in number when you write the final exam, I think, because I mean it makes sense that the students are not expected to remember each and everything from the slides, right? So there'll be fewer recall questions and more solving type of an application based questions. That is usually the trend in these NPTEL courses that I have observed in whatever courses I have TA'd for or taken up myself till now.
Actually, sir, I am trying to finish all the courses that are in the artificial intelligence domain of
Okay.
NPTEL.
Okay.
Uh, s- the first two are these two courses. I've already done one. This is the second one,
Uh-huh.
and I'm trying to do the rest. There are few more courses as well. Two, I guess there are more, two compulsory courses and two elective more to complete for the
Okay.
domain certification.
Okay. Okay. That's nice. That's nice to know. And all the best to you, Orkati, and anyone else who are interested in doing this course or the other courses or any of the courses actually. Uh, I
Thank you, sir.
Yeah, I'm trying for data science, domain data science.
that's nice.
So probably need to finish one more paper and then might get that one.
Yeah, that's nice. So there's one thing for certification, you need to do some X number of courses, but then I guess the learning never ends, right? So you can keep on doing as many courses, uh, and you can still learn something new every time you do something, right? Like,
Yeah, that's right.
yeah,
But if we get an opportunity to really apply in industrial scale, it will be very helpful.
yeah. I hope whatever you learn from this course and the other courses that eventually do help you in whatever you wish to pursue.
Could be.
Yeah. So Ashwini, so because you are here, I'll just mention something more on your suggestion. So
Yes, sir.
if there's something in specific or in particular that you need more examples on that maybe you could help if we discussed in the live sessions, you can feel free to mention it in the discussion forum as well. Okay, so I'll
Yes, sir, definitely. I will go through again through all the videos from week two. I found it, to be frank, hard to understand, and Miss, I just wanted to know the more explanation on that, where we can apply it practically, or where it will help me for the AI fundamentals. I mean, I wanted to clear my concepts, and I couldn't clear it from that videos. So I was just like, things are not going well for me actually. I'm
uh,
finding a struggle to understand the concept. I don't know why, or others might have not have the same problem, but I'm finding it actually tough.
no, no, it's fine if you're finding it tough. Eventually it'll get okay. So, is this the first time you're like going into a course related to AI?
No, no, I have completed machine learning from NPTEL itself, and
Uh-huh.
That was a wonderful session, and even I am finding your session very interesting and very informative. Many doubts are cleared from your videos, your session. So thanks to you.
Yeah, thanks for attending. I'm just trying my bit, but
So
yeah,
in next section, may I ask you the questions on assignment? Sorry, week 3.
yeah, sure, sure. So next week we
Okay.
are basically going to discuss the questions related to week 4 content basically. And
Okay.
in addition to that, any doubts you have from the previous 3 weeks,
Okay.
we can discuss those.
Okay, sir. Thanks. Thanks a lot.
Yeah.
So that time I can go for the particular topic. Is it okay?
Yeah. Just make sure, it'd be helpful for me if you could make a post in the discussion forum that you are interested in, or you would like if a certain specific subtopic or topic is discussed in more
Okay.
detail. So I could
Okay.
also prepare accordingly.
Yeah, sure, sir. Yeah, sure.
Yeah. Same for your case also, Mohan. So if you find any particular thing that maybe apart from the questions that we discussed today, if there's something in particular that you would like us to discuss next week, you can feel free to use the discussion forum. Uh,
Yeah, I'll do that.
yeah.
So one more
So
doubt
how do we
I would
do
like
this?
to discuss with you. May I?
Yeah, please go ahead.
Sir, I have taken the admission for PhD course, and just my approval came for the topic, and it is based on artificial neural network. But
Uh-huh.
and and that's the reason I want to clear the artificial intelligence in broad aspect, and want to clear my fundas where I can apply all this theoretical part to my research work.
Okay, so if you're
So, can you tell me where I can focus more for this kind of ANN development or ANN research work?
so artificial neural networks is something that you could say is a subset of artificial intelligence, but it has mostly to do with deep learning. Okay, so deep learning, it's a popular term these days, right? So it's
Yeah.
where you
Okay.
usually deal with different kinds of neural networks. In this course, we are not going to cover much of neural networks or deep learning aspect of artificial intelligence. This is mostly theoretical, mostly about knowledge representation and reasoning or logic, those kind of aspects of our AI.
Okay.
Uh,
Actually, I joined this course as the name suggests that it's a knowledge representation and reasoning.
yeah.
So I wanted to clear that how it is work, how the AI works actually. So that was my keen point to join this session, join this course.
So how AI
So would
works
you-
is actually a very difficult question to answer for even the experts, I guess. Uh, Uh, but yeah, so here you'll get one flavor of AI. Okay, so
Okay.
this course will be more theoretical, dealing with logic, right? So and the ANNs and stuff that you're talking about deal more with the practical aspect of it. Of course, there's a whole theory behind ANNs as well. It's more mathematical and more theoretical as well.
Okay.
But
Mm-hmm.
that is not something we are going to discuss in this course. This course will be mostly about applying, trying to learn different ways of representing the knowledge that we have, right? Like we saw some
Okay.
forms of, we are seeing some examples of knowledge bases, right? These are very
Okay.
simple knowledge bases. You could, in some of the weeks in this course, you will see some different practical ways of representing some set of knowledge, a set of knowledge or facts that you have, and
Okay.
then using different rules of inference or different ways of inference to derive certain things about or based on this knowledge base basically. So as the name suggests, we have knowledge representation is one part, and then
Mm-hmm.
reasoning based
Mm-hmm.
on that set of facts is another aspect of this course. If you are really interested in neural networks, I would suggest the deep learning course by Professor Mitesh Kapra. He
Okay.
is also a faculty at my institute, IIT Madras, and I think he also has a course on deep learning. But I'm not sure if it is offered this semester or will it be offered next
Yeah,
semester.
this time it is not on. So I joined the course which is relevant to my work.
Yeah,
So,
yeah. You can join it later as well. But that is a really nice course if you are really interested in
okay,
learning
sure,
more
sir.
about neural networks.
Okay, okay, sir.
Yeah,
Thanks a lot, sir.
yeah, yeah. You're welcome. Mohan, were you about to say something? I'm sorry if I interrupted you.
No, no, no. I'm okay. I'm just listening.
Okay.
And yeah, because I'm not prepared to put up the question without me going through those.
No, no, that's fine. You can take
Yes,
your
yeah,
time. Yeah.
yeah. Probably I'll pick next time.
Yeah, sure.
Well, thank you so much. Then I'm taking off.
Sure, sure,
Catch you later.
sure. Ah, is it Somil? I was not aware of that. Thanks for sharing that. So anyone interested can look it up. Look it up the message that Somil has sent in the chat. Okay, so I guess we are almost done with uh, the 2 hours that we have. So if there are no doubts, we can close the session now. Yeah, thanks again everyone for joining, and yeah, I hope to see you next week. And all the best for the assignment tomorrow.
Thank you, sir.
Yeah,
Thank you, sir.
thanks all.
Thank you, sir.
Thanks, Roshan.